Welcome to all of you. It's just really a pleasure to see so many faces here. This is a seminar learning about CGIAR's platform for big data in agriculture, building a global agricultural data and open innovation ecosystems for impact. This is part of the World Bank's data-driven and digital agriculture webinar series. We're just really very happy that through this series, we're able to engage with innovators, thought leaders, and as well as our own World Bank task team leaders who have been really innovating in the process of transforming agriculture and food systems using data-driven and digital agriculture. It's really a great pleasure for me to chair this session and to join all of you, because I really believe that we share the belief in the potential of smart agriculture for reducing poverty and promoting shared prosperity. We also share the passion for making data work for food security and agricultural productivity using data, not only from public sectors, but also increasingly data produced by private sectors and a crowdsource from our citizens, not only by improving or modernizing our conventional approach to produce those data and use those data, but also to increasingly adopt digital technologies. At the same time, I also believe we are really in the collective effort to explore how to make data findable, accessible, interoperable, and reusable for bigger impact. This is why, personally, I'm just really happy to join all of you, because at the Development Data Group at the bank, not only through the recently launched 50 by 2030 Data for Smart Agricultural Initiative, we help to support country governments to improve how they collect data. But also we have been exploring how to, through our development data partnership, to access data produced by private sectors to inform our operational colleagues in the process to learn how to make those data open to the extent possible, but at the same time to respect its confidentiality when it's necessary. This is why I'm just really pleased to welcome our colleagues from CGIAR to learn about their platform for big data in agriculture. My understanding is that this is a really wonderful platform aimed to harness the capabilities of big data to accelerate and enhance the impact of international agricultural research by organizing open data, convening partners to develop innovative ideas, and also to demonstrate the power of this big data analytics that can inspire a whole host of projects and lead to bigger impact. So with that, let me say that we really are looking forward to the presentations by our colleagues, because this is a process for us to learn, not only to really expand our effort in these particular areas in the agricultural sector, but also to see how we can learn to adopt your approaches in other sectors to really leverage new technology and new approaches for bigger impact. So with that, let me just quickly introduce our speakers. I won't go into their extensive bio. You can learn about their experience and their insight through the information we have shared. But let me welcome first Brian King, who leads the platform for big data in agriculture at CGIAR. We also have colleagues from CGIAR, Medha Devare, I hope I'm pronouncing your name right, who is an agronomist and microbial ecologist with experience in bioinformatics, and also leading a very important part of this platform. So let's wait to hear from her. I'm also very happy to welcome Robert Hijmans, who is a professor in the Department of Environmental Science and Policy at the University of California, Davis, who will share his use case of this platform and how he has been able to also have Julian Ramirez, who is an agricultural engineer with a PhD in environmental sciences from the University of Leeds. He also will share with us his experience in leading CIAT and connecting with this platform and also contributing to its further development. We also are very happy to have two of our own very dear colleagues, Holly Kranbeck and also Pramesh Shah, who is Holly is the program manager in our group in the data analytics and tools team, who has been leading the Develop Data partnership at the bank. And Pramesh is the global lead for data-driven digital agriculture in the agricultural and food GP at the World Bank. So with that quick introduction, let's get into the depths of what we're trying to do here. Let me first invite Brian to give us an overview of this big data platform, and then followed by Medha to give us more details of how they are making data available and how the data flows through their platform and how we can access and so on and so forth. Then followed by Robert and Julian with their use cases. So with that, Brian, can I just leave the floor to you?
Absolutely. Thank you, Haishan. Can you see my slides okay?
Yes, we can.
Okay, lovely. Sorry. So, I was just saying, we've got this a bit, sort of, mature prototype stage, but we have an internal system that we're excited about because it helps us to get a sense of the talent and capacity we have in our diffuse global organization, and also get a view on who those people are collaborating with, or at least, publishing with, which obviously is a pretty good indicator. Because this collaboration piece is sort of central to the next module, which we call convene. And it's looking at, in a various number of ways, what are the kinds of partnerships that we need to be developing to move digital agriculture forward. And so, I mean, the platform as a program serves as a kind of an interface for partnerships, and develops services and so forth that are, rather than 13 to 15 bilateral relationships, we can help to serve as a kind of point of interface for our global organization with external partners. We've got a really interesting aspect of the program that's kind of coming into its own in the last year, of these technical communities of practice. And these are mostly external communities of practice, but they're kind of a bit more domain and technical discipline specific around this digital in agriculture question. So for example, a really good example is there's a community of practice just looking at socioeconomic data, recognizing that, we estimate we have about 800,000 individual survey responses per year, and until a program came along with a real strong mandate and some person hours and some funding to start to capture the power of that, harnessing the analytic power of all of that sense and response capability in the world was kind of getting lost. And so a community of practice formed, and it's just looking at, okay, how do we describe and annotate socioeconomic data? How do we harmonize on the kinds of questions that are being asked? How do we make sure that the data then are discoverable and we can start accelerating our learning as an organization and hopefully as a participant in the larger ecosystem? There are communities for socioeconomic data, geospatial analysis, ontologies, livestock data, data-driven agronomy, and crop modeling. And now, and most recently, we've sort of allied with, and we're bringing into the fold as well, the Pan CGIAR community of practice on information and data management. So, we recognize we can't do it alone, and we need these mechanisms for being able to engage with the wider world, source evidence, source good ideas, and then have folks that we can engage with on validating those. A key way that we engage is our global convention, and we by convention we sort of move region by region each year. Latin America, Africa, Asia, Latin America, Africa, Asia, and it's a really great opportunity to engage with stakeholders in those regions, the digital ag ecosystem, broadly in those regions, and also to kind of showcase how our researchers and our centers are working in those regions as well. It's virtual this year. It's next month. You're all invited. I will see you online again in a while. So, and then lastly, this thing we're talking about with Inspire. So just briefly, we have a Pan CGIAR digital innovation process where we ask our researchers to team up with external entities of any type, and literally any type. It can be global firms, statistics bureau, ag tech startups, other research organizations. But there needs to be a partnership, and the parties need to come together to try to create something new, something that neither side would be able to do on their own, and it needs to be digital. And then in terms of the categories, these are ones that we're seeing up on the screen now. These are ones we sourced from our own research programs, but increasingly in kind of co-design with some of our stakeholders. So just really briefly, we're looking at food systems for recognizing that there's a real significant data gap still, and a frequency of data gap in understanding how food flows are working and why, and just what's going on in food systems. And we have an array of data and tools out in the world that we should be making more active and applied use of. Resilience is obviously a sort of mainstay of development theory and thinking. It's also a bit poorly defined sometimes. And so how do we get more precision of definition? How do we measure that changes in what resilience is, and how do we operationalize that? If we can't measure it, how do we operationalize it? So again, data and tools and innovations to help us do that as a development community. Sensing and renewing ecosystems recognizes that similarly to revealing food systems, we could also really gain from some understanding to better understand the natural resource base and the ecological base of agriculture. Again, the ability to measure and act and operationalize is a goal here. And then this last one is sustaining farm income. It comes from the recognition that for sustainable practices to scale and grow and so forth, we also need to have a link to income. We need to have sustainable farm income and sustainable practices. And so this one's defined very broadly. It can be really anywhere in any entry point in a food system, but there needs to be those dual benefits of sustainable practices and income down to farmers or small agri-food businesses. And so I will stop there just to say that all of these things, including the challenge that I just mentioned, are open processes. And we're looking to continue to kind of reinforce and build through partnerships in all of them. All of the development we do are open. Software development we do is open. All of them have a partnership kind of dimension to them, and we feel that this is how we can accelerate sourcing, validating, vetting, and fostering digital agriculture innovations across this whole spectrum from research to impact. So I will stop there.
Yeah.
And someone's going to show us the data.
Yeah, thank you so much, Brian. You definitely have given us a very sweet teaser, and we really want to hear more. But before I move on to Medha, let me quickly mention it's wonderful to see the number of participants keeps on increasing. But I just want to know that there's a lot of rich information you might want to jot down notes, but we will provide you the presentations and recordings and a curated chat, so you won't miss that. In the meanwhile, I do encourage you, along with the presentation, if you have any questions, please jot them down in the chat so that we can organize our discussions subsequently. Okay, with that, may I invite Medha, please.
Okay, great. I hope you can hear me, and I hope you can see my screen. It should be showing full screen right now. So Brian provided a grounding for the platform as a whole. I lead the Organize module of the Big Data Platform, and Jaewoo Koo, who's also at IFPRI with me as a senior research fellow, is sort of my comrade in arms in doing that, along with the rest of everybody involved in the Big Data Platform. And to some extent at CGIAR contributes to this, because we rely very closely on the information and data managers, as well as the community, some of the communities of practice. So I'm going to dive in and show you a little bit of what we're actually doing with the data. I'm going to start here because I think this is an artist's rendition of a farm in an emerging economy. I think it's fairly clear to most of us that agriculture is getting much more digital and digitized, and we might be able to envision a future not too distant that looks something like this, with a lot of data, very rich data and large amounts of it increasingly coming from devices. In order to be able to harness that, hopefully we're already focusing on data-driven solutions, but increasingly we're going to be looking at big data-driven solutions, I think. And for that, of course, we need to be able to find and access data. We need to be able to interpret what that data is telling us. We need to be able to interoperate across it. We need to be able to aggregate it. And it would be nice if we could visualize it. And of course, in order to develop solutions and insights, we do need to be able to analyze the data. So that's kind of the grounding for what we do through Organize. I want to lay the groundwork and echo something that Hijmans said. Hold on one second, it's somebody at the door. Right, I'll just keep going. So this is one of the problems about working from home, right? It's so getting back to this, research data we assume will be open by default. That's our sort of our default position. However, open is no longer enough. We need data to be open by default, but we also need it to be fair, which means it needs to be findable, it needs to be accessible, it needs to be interoperable and reusable, as Hijmans said. And as will be clear, I think, from the use cases that we are going to see coming up. Right, so what are we doing to make this data in general, agricultural data, open and fair? What I'm showing here might seem a little bit overwhelming to start with, but I'm going to run you quickly through the key pieces of this. So this is, in a sense, is our approach to making data open and fair and providing some value for a number of different stakeholders, from researchers, policymakers, to farmers, and a number of other stakeholders that may not be listed here. And let's see if I can get back to my presentation. The heart of this is the Guardian data discovery portal, and I'll dive into it a little bit more, but this is the heart of our data ecosystem. And what it does is to make discoverable data assets, publications and data that sit in a number of different places. And you can see that on the left-hand side with these kind of greenish pillboxes. So the data and publications you see are coming from all of the CGIAR centers, USAID, what used to be DFID, the World Bank's LSMS data is in there as well. We also have data from the USDA's Ag Data Commons, from the Crop Trust's Gene Bank's platforms, Genesis system, the Government of India's Open Data Portal, and this list keeps growing. So that is metadata harvesting primarily. We're not holding the resources themselves. But the key thing is that any of the data in Guardian is then available for wider discovery and use. It is being indexed by Google, for instance, and it's out there and available for anyone to use. In order to have, the kind of data that I started out talking about, the aggregatable data, the interoperable data, we are also trying to attack that problem, essentially, of being able to generate data that's already fair. So the development of digital tools that are based on standards like ontologies and controlled vocabularies to collect data that is already born fair, for instance. And then there are, we've also built workflows, the FAIR workflows. These will be released by early October, that will help users, researchers, data managers, for instance, to comply with these standards very easily without necessarily having to really dive into ontologies or even necessarily know what they are. We want to make it easy for people to be able to do this. Lastly, I had talked about visualization and analysis. So we're also building in data exploration and mapping tools and capabilities, and pipelines, analytical pipelines, with the holy grail. You hear a little bit more of this in my last slide, probably, but the holy grail of making data model ready. I just saw a question pop up about FAO, and I will say that FAO's AGRIS is already harvesting Guardian in a sense. So it's making visible all of the data assets that are in Guardian to enrich AGRIS. So instead of having to go to multiple different places, now they can go to one source to make that more visible. Right, so I'm going to dive in further now and try to talk from the point of view of users. So what if I want to find data on nutrition? In relation, particularly with the gendered aspect to it. So in relation to as it affects women, for instance. So here what I've done is a search in Guardian on nutrition and women, very cross-cutting kind of search. And I see that I get over 800 publications and almost 300 data sets. When I look at those data sets, that's what I'm showing you here, a screen grab. You see that they come from a number of CGIAR centers, IFPRI, ILRI, and SIP here, but they also, as I said, are coming from FCDO, which is what used to be DFID. I don't even want to try remembering what that stands for, Foreign Commonwealth Development Office, I think. But in the USAID, the data.gov.in portal, so that's the Indian government's open data portal, and the World Bank's LSMS data. So, and there's USDA's Ag Data Commons as well, although it's not showing up on the screen. And as I said, as we go further and further, this list keeps growing. Now, when you dive into a data set, what does that look like? So what you see is usually a machine readable license. Of course, you see the title, the source, the authors, you know, a summary, etc. But on the left-hand panel here, you see access rights with the machine-readable data. You see the links to the data set itself, because, as I said, we're not holding that data. We're just making it discoverable, at least for now. And then you see a geographic context, if there is one. So a quick view of where's this data, you know, what does this data pertain to geographically? Now, if you go further down, you see a sort of a cloud of keywords. And this is the work that our data managers are doing largely to annotate data sets well. But it's the keywords that they add are also being enriched through text mining with terms from Agravoc, the control vocabulary, and also ontologies where they make sense. At the very bottom, you will see relevant publications, and these are algorithms that operate in the background to try and tie relevant publications to data sets, or on the flip side, data sets to the publication you might be looking at. Oftentimes, you don't have a direct link between publications that underlie or are built on a particular data set. So this is an attempt to kind of provide context for data users. Lastly, what you see on the left here for every resource, data set or publication, is what we call a fair compliance score. And this is not in any way to be, you know, policing or anything like that. It's a way to try and help everybody get their assets to be more fair than they show up right now. And we have workflows, as I said, to enable people to do this. That'll hopefully help them get further along that path. So that's what I'll say about the FAIR metrics, and I can answer more questions about that as we go along. Now, a lot of the data that is available in Guardian in a sort of a more consistent format and rich format is available that way because Guardian enriches the metadata that's native, that comes with that resource. Ideally, what we'd like to be doing, of course, is to generate data that's already born fair, as I said. So this is just an example of our attempt to try and make agronomic data fair by generating field books that are already based on some of these ontologies. And so those are the interoperability standards. And there is adherence with a standard metadata schema as well. So it makes it very easy then for researchers who don't have to do any more work. You know, by using this agrofems, as we call it, they are able to generate fair data. And that's the hope. And then, of course, for high-value legacy data, there are the FAIR workflows I mentioned earlier. Right, so switching gears a little bit, now you've found the data. You want to be able to perhaps explore the data visually. So I'm showing you here a screen grab from our data exploration piece of the Guardian data ecosystem. What I've done is leverage a global data set. These are crop production estimates, global crop production estimates, the outputs of the SPAM model. And they're available right now for 2000, 2005, 2010, and 2017 data will soon be up here. This is for over 30 crops. So here I've chosen rice and wheat. And I have said I want to know sort of global yield, rain-fed yield of rice and wheat. And it drops it on the map, so I can look at that. And I've chosen, then I've gone here over to my right-hand panel here. I've chosen the pin icon. I've dropped it on Mozambique. And when I do that, it pops up a box for Mozambique and tells me what the summary statistics are for that parameter, in this case, rain-fed yield. And for Africa, we've also tied in work that Jawu and his team have done at IFPRI with something called Data Africa, so that you can click on that little round pie-like icon, and you get much more information on that particular country. So that's kind of nice, being able to, you know, bring together more streams of data to enrich what you're already seeing. So you don't have to go to multiple places. But then you can also, what you can also do is to use the polygon icon that I'm pointing my arrow to right now on the right. And you draw your polygon. You can't see it very well, but it's the light green area there in the kind of around the two pins that you see on Mozambique. And it will pop up the statistics for that as well. And in an iteration that will soon be released, you will be able to download the data for those, what's within those polygons. So it's a nice way to query data The other thing also is we've implemented on top of this sort of the ability to dive down further beyond that country level admin layer into lower admin layers, and be able to extract the data for a particular admin layer rather than a polygon. So that will all be released pretty soon. Right, now you've sort of visualized your data. You want to be able to set up a team, your lab group or your project group, and you want to be able to work within just your team to find and securely share data. Maybe you're dealing with sensitive data, for whatever reason you want that secure sharing, which is becoming increasingly important, and you want to be able to analyze data. So for that, we have a solution called CG Labs. You'll also hear about that. This is a very mature prototype. In order to get into again, this is all open to anybody who wants to use any of our tools. In order to use CG Labs, you must set up an account with Globus. Globus is a software that underlies this and makes anything you do in terms of data exchange or transfer HIPAA compliant. So that means it adheres to the strictest privacy regulations. And that's kind of a reassuring thing. So the sort of in a nutshell, what CG Labs allows you to do, it is an analytical pipeline, and it allows you to find data. It allows you to collaborate with your team at different levels, at customizable levels, really, and it allows you to some level of security management through the single sign-on. And of course, the private data that I mentioned. Of course, all of this is open source, so it's nice as well, because everything we do, we also try to make available on GitHub open source. So the kinds of things that CG Labs allows in terms of, for instance, a global geospatial exploration, for instance, which is what I'm showing you here. I'm showing you the downscaled CMIP6 data set, 7 or 8 terabytes data set. What I've done here is chosen a model, chosen a parameter. I can choose my scenario. There are 4 scenarios there. And it'll run through, I can either run the video through, essentially make it play through 2030 to 2080, or I can move the cursor myself, choose a time frame, and go to that. But what's nice is the feature that I talked about earlier that's also implemented here. So with 4 clicks, I can get to downloadable data as either GeoJSON or CSV. So here, what you would do is what I said earlier. You select your CMIP6 model, your CNRM, or in this case BCC. You're pinning your region. So here we're showing you the functionality of the admin level, being able to dive down to admin level 2 in this case. You're selecting a time period for which you want the data, and then you download it, either by clicking on the download raw data icon within the little query square that pops up, or on the right-hand side with the save disk icon. So it's really being able to visualize data, interactively query it as you're looking at stuff, which is very nice, increasingly moving towards the ability to really leverage data effectively. The last thing I want to speak about is in terms of CG Labs is the ability to actually do the analytics. So you've saved some data sets, and on the left-hand panel there, under name, you can see the data sets, some of the data sets that I saved. And I can work with those data sets by calling different libraries. Right now we have, and in this case, crop models. So this is WOFOST. And we also have DSAT as the R version. This is an R and Python environment. And you can also work with your team as you build code, as you change, as you download code from Git. You can go up and down essentially very simply and easily, and all of this without having to rely on FTP, email, Dropbox to exchange data or code, etc. So this is kind of a nice computing environment that lets you do that. So what's coming soon to CG Labs is something I want to highlight. Work that we're doing collaboratively with Cheryl Porter and her team at the University of Florida as part of the larger AgMIP project, which is the Agricultural Model Intercomparison and Improvement Project. And the holy grail here, which we're quite far from still, is being able to find data via Guardian, for instance, to answer a question like this. I need to recommend sustainable intensification practices for West Africa. So Ava here would then go to Guardian, find a number of data sets for West Africa, for a number of crops perhaps, and then be able to, because of the mappings that have been made between the ICASA variables that are used by UNmet and some of the ontologies that are in use, like the agronomy ontology and the crop ontology, if the data were, particularly if the data were already compliant with these, if they were already interoperable in that sense, then this would be much easier, because then you would be able to get very quickly to model-ready data through the AgMap translators. So what we're trying to build in now to CG Labs is those translators to be able to enable at least the baby steps towards this, or at least be able to find the data, translate it, and then take it away with you to maybe have to manipulate, probably have to manipulate further before you can shove it into a crop model. We're getting there, baby steps, but the idea is with as few clicks as possible to enable that plug and play capability once you find the data. That's the overall message here. So that's pretty much all I want to say. But okay, great. You know, so you've shown all of this stuff. So what? You know, I would like to sort of turn over now to Robert, who's going to talk much more about the so what, by diving much deeper into what happens when you actually find the data. And he's much less math averse than I am. I think I'm permanently stuck in this stage 4 of depression. I've never been terribly good at math. And so, you know, this is kind of, you know, increasingly being able to leverage the kinds of technologies that we're talking about is what Robert will be talking about shortly. So over to you, Robert.
Thank you so much, Medha. You've done such a fantastic job. You actually gained us a few minutes, but I see that, first of all, what a great platform. It's really inspiring. But I see there are quite a few questions might, you know, be easily clarified. Would you like to do that? So, because I know we have so many inquiring minds that they might not settle before we move on. Just a few minutes. For example, do the data set include the social economic data, whether it's programmed in R or Python? You know, some of those quick questions.
Yes, so the data sets do include socioeconomic data as well. Not all of that data, so as I said, we're harvesting metadata. So you may have to actually request some of those data sets if they have sensitive information, for instance, or are not blurred up enough. You may actually have to go in and request the data set, which is not really where we want to be, but it is where we are now. So it's, again, those baby steps. You know, we're not 100% of the way there, but the short answer is absolutely, there is socioeconomic data there. In terms of how publications get tagged to be included in Guardian, ideally, you would be adhering to some form of the Dublin Core metadata schema. But all of this has been developed, by the way, by a fantastic crack team of developers at SIO. They're based in Greece, and I think one or two of them may be on this call as well. But you know, so they're able to, it seems like, consume almost anything and make it visible in Guardian. I've been quite astonished at what they can do. So that's not critical. But the other piece of this is the FAIR workflow. So if you want to come in and use our FAIR workflow, you can then adhere to the consistent metadata schema, tag your data sets, and make them available that way. And we can talk more about that, Laura, as we go on. In terms of the coding language, it's R or Python for CG Labs. And then let's see, will the data remain open forever? That's the million-dollar question. I hope, I mean, I'd love to be able to say yes, but I don't know the answer to that. I mean, I would hope that we're moving increasingly in that direction. But that is the nuance of FAIR. I mean, in other words, if data cannot be open, can we at least find it, access it? You know, depending on who you are, depending on the licenses associated with that. So fair adds a nuance where it doesn't just become open or not open. There's a little bit more ground in between and allows you to work with that. My own hope is that we move much further along the path towards open, that it doesn't remain something that scares us in the agricultural sector. The biomedical sector has done this, and the sky has not fallen down. That's a message I keep reinforcing, because the transformative power in biomedicine, in medicine, and in gene therapies, for instance, and everything we can do is largely because the data was mandated to be open. It's transformed what we can do. So that's my hope in that. Is that good for now, or I'm trying to read quickly? Okay.
Yeah.
I don't want to take more time.
No, that's great. We can cover others and also give you time to go through the question while we're listening to Robert. Yes, sure. Robert, please. I think Robert will share with us one of the use cases in Africa. Yeah, please, Robert. Do we have a presentation need to be brought up? I'm sure someone is controlling that. We can't hear you somehow, Robert. Can anyone hear Robert? Yeah, we can't hear you.
We can't hear.
Yeah, we can't hear.
How about like this?
Yes, now it's better. Yes.
Okay. Very good. You can see me too?
Perfect.
All right. And now I'll try to share my screen. Is that working?
Perfect.
Wonderful. Well, hello, everybody. Thank you very much for being here with us today. And it's a pleasure to very briefly present some research using the open data that Medha just has described. The work I'll be talking about is mainly work by Camila Bonilla, who's now at CIAT, who used to be a graduate student in my lab at UC Davis. I'm Robert Hijmans, and his work is mostly in collaboration with Jordan Chamberlain at CIMMYT in Nairobi and a few other people. And so I'm going to talk about profitability of fertilizer use in Africa. And really the question, let me see if I can get the next slide. The question we were asking, or trying to respond to, is why is fertilizer use so low? It's well known that crop yields in Africa are relatively low compared to other continents. And this is for a large part because of relatively low soil fertility. So then why don't farmers use more fertilizer? Well, there's many theories and hypotheses about them, including low crop response because of maybe poor soils or climate. Maybe the prices aren't right. Maybe there's too much uncertainty in the weather. And there's a few other hypotheses. I tend to say they're probably all true, but it kind of depends where and when. And so to be able to do better research or policy on crop production and fertilizer use, we need to get a bit better insight rather than saying, well, it may all be true, it depends on where you are, or another vague answer. But to do that, we need to have site-specific, and I'm not saying within a field or a particular field, but for small regions, we need to understand, well, what is the crop response to fertilizer? So we need some kind of a model for that. And we also need to have the prices, input and output prices. So if we know what fertilizer costs, we know the benefit of a certain amount of fertilizer in terms of crop yields, then we can look at profitability. So how to do that? Well, there's different ways to do that, but we took sort of this data science approach, building on the new abilities that we have because of Guardian and the data that's underneath it, the open data from the CGIAR and others. So the first thing is this findable and accessible data. So we went to Guardian, searched essentially for maize and fertilizer, spelled correctly in that case, and some other search terms like that. trials, and we found something in the order a little bit more than 100 data sets, mostly trials, but also a few surveys that covered 760 locations and over 12,000 observations. That was pretty amazing, right? So instead of asking for a couple $1 million grants to go across the continent and take all these samples, which would be a great thing to do, I'm sure. We stayed in our office. Camila did anyway, and in a couple of months, she was able to find all this data and download it. Sorry, I'm trying to get to the next slide here. Up now. Now the question is it interoperable, right? We have all these data sets. How do we put them together? Now there's a whole lot of improvements that could be made over time, but I would say to a large extent, well, yeah, they are interoperable if you work on it. So in our case, the big R is because we just write an R script for every single data set. That script includes the first line that automatically downloads the data. So we go to Guardian, find the data set, find the DOI, so the unique identifier of the data, and then we've written these functions that then say, okay, download the data, and then start processing it into a standard format. Of course, that's a lot of work because you have to do this 102 times, and every data set is somewhat different, but it's doable. It's certainly an area where if data sets would be provided already with standard terms, our life would have been much easier. Having said that, the way we think about this now, it's also that this is really a workflow that in itself is relevant. So here in this figure, I show sort of how we've set this up, where on the top you see an R script for every data set. So at this point, there should be 100 of these R scripts. Those go together into a repository at GitHub that is not open yet, but we're still working on the final publication, but it will be open sometime this year. And then you can download or you can pull that to your own computer, run a single R script that the mother script sort of that runs all of these individual scripts, downloads the data, aggregates it into a database, and then you can either go to your left and you do some analysis with it, but also the idea is then we'll upload that again to a repository so that Guardian can find it, and many other people can ask similar, perhaps, or related questions, but different questions. What's very important about that to me is also that, is that fact. We put these data together to ask a particular question that I will talk about a little bit more. But it's entirely likely that other people will want to expand the database, ask somewhat different questions, build maybe an application on top of it that we are not interested in. So rather having everybody sort of having to go through the same hoops, let's build this workflow that people can then reproduce and build on. And that's really sort of maybe the main takeaway of my talk, that having open data has often been portrayed in the past as, oh, that's great, now you can reproduce research. Reproducing research is important because that's how we can check if we agree with the conclusions and whatnot. But it's also a bit boring. It's much more interesting part of open data is that we can do new things with old data. So I'll go back to our particular case study, which was trying to look at soil fertility and fertilizer use in sub-Saharan Africa. And so here's just some of the raw data. When we have nitrogen fertilization at the bottom horizontal axis, and maize yield at the vertical axis. Well, what you see is if you put all these data together, there seems to be a somewhat reasonable response that it's, first you get a good response, and after a while that levels off. You add more fertilizer, it doesn't help anymore because there's some other factor that limits the production. But the other thing you see, of course, that is huge variability. If it basically says with 0 fertilizer, you can have a yield between 0 and 6,000 kilograms, and with 50 between 1,000 and, well, maybe 10,000 kilograms per hectare. And that's expected because it depends where you are. It depends what your soil type is. It depends on the amount of rainfall. It depends on the temperature. So there's all this additional variability in interactions of environmental factors and agronomy and management factors, the varieties that are hard to depict in a two-dimensional figure. It also used to be difficult to model that in a statistical sense. But now with these machine learning algorithms, it is relatively straightforward to build reasonable models that have strong predictive power, and that's what we did. So we rather than doing these one variable simple models, we used the random forest algorithm to build a predictive model that uses soil pH, rainfall, and variables like that, and of course fertilizer use to predict maize yield. And then that allows us to make predictions like this. Here you don't see the yield, but you see, what our predicted response to nitrogen fertilizer and our predicted response to fertilizer, phosphorus fertilizer. So at the left, you see, well, if you added, I think it's 50 kilograms of nitrogen, what would be the per kilogram maize yield be? So essentially, on average, it's somewhere in between 25 kilogram of maize per kilogram of fertilizer at the very low levels of fertilizer use, because remember the diminishing returns. The interesting thing is also you see that phosphate, the response of phosphate is quite different in terms of the spatial pattern. For example, you see in the Sahel, in the very northern part of sub-Saharan Africa, nitrogen response is relatively low, but phosphorus response, or response of phosphorus is relatively large. All right, so this gives us a site-specific estimate of fertilizer, of crop response to fertilizer that was gleaned from these 12,000 observations that we got through Guardian. We had similar work to get price data, subnational price data. I'm not going to go into the details. If you have papers on this, at the left hand you see estimated urea prices, based by combining market price data from many countries and many markets. And at the right hand you see maize price data, although the maize price data actually has much more further detail in it, because it's also very much depends on when, what we find is large seasonality in prices. But let's just accept for now we have these crop responses, we have prices, and then we can put it together to figure out, well, okay, how profitable is fertilizer use, and how much could you make by applying fertilizer. So this is one quick result. The main point here is to show that, well, there is, if you look at the continent, there's huge variability between countries. For example, Uganda, although the soils are pretty good, the prices are pretty bad for fertilizer use, meaning fertilizer expensive, maize is cheap. Whereas Kenya, so the opposite is a similar case in terms of soil fertility, but much better prices. South Africa, Zimbabwe, very good areas of fertilizer use. Other places not so much. But there's also important subnational variation within these countries that's sort of hard to see at this aggregate level. So just to conclude of this, quick vignette of an example of a research study, and obviously, I could talk much more about the implications for whether it's extension or research and whatnot. But my point here is really that there are these interesting opportunities to use old data for new research and development. My thing is more research, but you could also imagine that you would start using these and a whole lot of other sort of fertilizer response data that is out there with NGOs and others to help make sort of advisory systems and whatnot. This is the other thing I pointed out to make is that what we've built and are currently, is getting ready for publication is an empirical model that is imperfect. And there's other alternative models you could look at, but the promise of sort of where the world is going is that as more data becomes available, these empirical models will get better and better. So that there's really a lot of new stuff that we'll be able to learn from them. And then finally, data aggregation will become increasingly important. So it's not just the individual data sets, but it's really, so how do we put them together? Both, and of course, there's a lot of talk about sort of the, ontologies and sort of, and shared vocabulary so that that can be done somewhat automatically. But I think it also takes, dedicated people who can look at each individual data set and make assessments, make notes, and make some informed decisions of how to best aggregate these through reproducible workflows, as I talked about, such that others can either disagree or can do a pull request and get up and improve past work collaboratively. So those are my slides, and thank you very much for your attention.
Thanks a lot, Robert. This is really fascinating. So thank you so much for sharing with us. Let's quickly move to Julian, who will be talking about the CG labs that Medha mentioned in her presentations, which made us all very curious. So Julian, please.
Right. Can you see my screen?
Yes, we can.
Right.
Thank
Great.
you.
Yeah, thank you for having me. And as you said, Haishan, I will be trying to talk about, try and present a second case study, different to Robert's, but we're using the CG Labs capability to handle relatively big amounts of data to address a complex problem. And the problem that we're trying, what I'm going to try to go through is I'll give you a little bit of context of what the problem is, and then I'll go through what we're doing, and then finally how we're doing it through CG Labs. So what we're trying to address is climate change. Climate change is an extremely complex problem where you may have different solutions, because solutions depend on the geographic space you're looking at. They also depend on the time frame. Solutions are also complicated to implement because they also depend on the capacity of people to implement solutions, on the capacity of people to access finance, and so it's what you would call a wicked problem. You don't really know where to start with and where to start, and you don't and it's very hard to sort of address it all at once. But fortunately, we have a lot of data that at least helps us understand the problem, and then hopefully through different kinds of models that help us understand, help us understand what the response of crops or livestock or socioeconomic systems are to climate change. Then they eventually may help us also get to figuring out what adaptation options are there, and how much these adaptation options may cost. The problem is that when you want to look at climate change impacts and adaptation at the continental or at the globe, let alone at the global scale, the amount of data that you have to deal with because of the different dimensions, because of multiple crops, multiple cropping systems, multiple geographies and dimensions of the problem, the amount of data is quite large. And I'll come back to that point on how we have been able to handle this amount of information. But now I'm going to dive into the two results, and I think, I mean, presenting in a seminar with the World Bank, I wanted to highlight the sort of two examples of investment prioritization. Basically, the first one is called the Smallholder Adaptation Atlas. So this is a project that we're developing with the Gates Foundation, where the aim of the project is basically to develop an atlas that supports the investment prioritization by the Global Commission on Adaptation, right? So the Global Commission on Adaptation produced a report that was launched in the third quarter of last year, and this report puts together a lot of information and comes up with a number of potential investments for agriculture. Now, the question that we ask is, where do these investments have the largest impact? In which countries, in which specific environments, for which kinds of smallholder farmers? And this is kind of the question. This is the question that we set out to answer here. So what we have been able to do with the Smallholder Adaptation Atlas is to put together a lot of different data sets for different hazards, for different climate scenarios, for a number of different crops, and also livestock production systems, and sort of human population as well, and with continental coverage, totaling more than 100,000 different individual layers of information, and then layer that with a number of adaptation options that we've been that we've been looking into and modeling. And here you see an example of heat stress occurrence in a future climate scenario. And that's just an example of one of the layers that we've been looking at. Through different kinds of model-based analysis, we've been able to come up with a first idea of with a way of prioritizing adaptation options, basically. So this is an example for the AGRA countries, where we see adaptation solutions for the whole set of countries assessed in terms of scale of the impact and also the sort of agreement of evidence. So if you think about those two dimensions, which are the sort of main dimensions that we think are important in prioritizing investment, one is, okay, how much return you're going to have. The second one is how confident I am that I'm actually going to get that kind of result. So what we see is investment in research and development is up there, high confidence, high impact, but also the use of inorganic input seems to be high confidence and high impact. There's going to be geographic variation, for example, in the use of inorganic fertilizer, like Robert actually described in his previous study. On the other hand, you see options like adaptation actions like conservation agriculture having less impact, but also less evidence in the reported in less evidence and less sort of confidence in the model-based results and underpinning data. So at the end of the day, as I just said in the previous slide, we've been able to put together a large amount of data to answer what seems to be a relatively simple question: what works best for a set of countries or for a particular geography, but actually it's quite a complex question to answer. The second sort of example that I want to bring was at the national scale. We're doing a similar type of exercise with the world, actually supported by the World Bank, where we're trying to understand. We've already done this for a couple of countries, and now we're doing it for some more, including Jordan. And so for a particular geography, what we set out to understand is the specific climate hazards and the risks that those hazards imply. So here you can see an example for Kenya for drought, right? So these maps shows different levels of drought, and we can come up with similar kinds of maps for a number of different hazards that may or may not affect a given geography. Based on data analysis and modeling, we can come up, we can get an idea of the frequency and impact of those hazards, and then be able to assess risk. Why is that useful? Because then once we understand risk, we can come up with options, we can propose options, and then assess those options for the return investment. And all of those analysis pipeline, of course, as Robert pointed out in his previous presentation, we develop scripts and put together things to be able to replicate those analyses. But again, as I was mentioning at the beginning of my presentation, a lot of this data is quite big. Often these projects involve collaborations across multiple institutions. And then the question is, of course, this is not the type of thing that you would run in your institutional laptop at home, right? So what do we do? And all of this, what I've showed, and some more projects have been all powered by CG Labs, by CG Labs capabilities. So why have we used CG Labs? So the first thing is that it's really easy to use. It's mounted on a Linux-based system, but the interface is really easy to use. You have 3 different ways of sort of performing analysis. Of course, the normal console, but you also have notebooks which allow for replicability of everything you're doing. You can connect to online code repositories very easily, and you can connect to the whole set of Guardian data, and it's all very easy to do. You can share CG Labs capabilities because it's done through something called Globus, which is providing all kind of security protocols. You can share with anybody within your organization, but also outside your organization. So that enables collaboration quite effectively. It's also, so we've been during this last few months that we've been working with CG Labs quite intensely. We've got great tech support from the development team. It's fully customizable, and so we've been, through our work with CG Labs, we've been installing a number of new libraries and packages and sort of customizing it to exactly the types of analytics that we needed to do, so that once you are there in the system, everything is there. You don't have to worry about installing new software packages and stuff like that. And another thing is, as Medha mentioned, is sort of CGIAR data ready, so you can easily link all of the CGIAR universe of information into CG Labs really easily without downloading, without worrying about storage. One cautionary note here is that, of course, data may come in different formats and in different ways, and as Robert mentioned, you may need to work out how to make the data uniform and working for your case, for your analysis. Where we've been needing to use data from which is not CGIAR or which is not CGIAR, it's the system is really fast for downloading anything that's on the web. So that also is not a limitation. Of course, in that case, you would need to think about the storage space. It's easily scalable, so once you mount it on a particular cloud computing infrastructure, you can scale out that infrastructure, scale it down, and they're in a relatively straightforward way. Finally, replicability, because you can work with notebooks, then the replicability is really good, and you can use this also for capacity building. And finally, you can streamline all of your analysis in a way that, because you have a platform which is standardized, you can write your code in a way that anybody can run it from anywhere without really needing to adjust anything. And so a little bit more maybe detail how we work with it. So say this is CG Labs. This is me here in the Netherlands working from home. People in my team from Cali, they can access the platform at any time. Also, people from outside our organization, say one of our collaborators in eCraft, can access CG Labs. CG Labs can be connected to any code repository. We mostly work with GitHub, and it can be connected to any kind of data, whether it's CGIAR data, which you can plug in directly very quickly, but also you can download stuff. Importantly, you can also even upload your own data from your laptop or from the data storage system in your own institution. So you can really tap into whatever resource you want in an efficient, cost-effective way, and then you can connect it to any computing resource. So that's what I wanted to share. Thanks.
Thank you very much, Julian, and to both you and Robert. Now you can also have a glance at the chat to see whether there are any questions for you while we are inviting our two discussants to share their thoughts. First, let me invite Holly.
Hey, thank you. And thank you to all of the speakers. I think what you've built is fantastic. These are remarkable platforms that create tremendous value from data collected by international organizations. So taking these data and being able to create an infrastructure to make them discoverable and transformable into insights is just such a useful service. There's a lot to like and learn from here. I like how you leverage the community described by Brian to support the development of data standards. And I like how you encourage the use of these standards and FAIR principles through your data discovery platform, using FAIR like a badge. It's very clever. I like how you make it easy to find the data with the platform that Medha had presented, and that it includes visualization tools, which I think users, particularly non-technical users, find valuable. I think it's a clever idea to take the Globus subscription that solves a lot of challenges, because through that you can facilitate the data ingest, storage, and access management without having to build out a huge internal IT architecture and team to facilitate and manage. It's a good thing to outsource while you can leave the CGIAR team to focus more on the substance. I like how you make it easier for data scientists to get started, relying on GitHub for code collaboration. And I like how Robert mentioned in his presentation how you support dissemination of derived data products through the same platform. So if someone creates a new data set through these tools, they get fed back into Guardian so that others can use them. It's really nicely done. I know myself personally, I would be interested in hearing a little bit about the business model for this. So from the perspective of CGIAR, how you support the costs of the subscription and the labs and Guardian, and it's just a tremendous amount of work. So just curious. And also from the user perspective. So with the tools presented by Julian at the end. So if a user wants to upload their data and do these analytics on your compute, how that works, so that it's more clear, because I know it can't be all free, but if it is, that would be amazing, and we'll be all over it. I think I see a couple of challenges, probably. And we maybe a challenge that we share, being able to link these incredible resources to use cases. Brian mentioned in the beginning I think it was under Inspire, the challenges. And I thought that was a really good idea to introduce the data sets and resources you have to practitioners interested in certain challenges. And I'm wondering how well that works out. And whether you're looking at other ways to be able to link these resources to users. I know on our side, we find one of the challenges is often our domain sector experts who are most intimate with the challenges aren't necessarily also data scientists. And sometimes it's difficult to make that link. So yeah. And the other challenge might be in introducing private sector data. Often the private sector will collect data that is of more granularity and lower latency than what's collected by governments and the international organizations. And I guess particularly now with the pandemic and locusts, the value of these data have become pretty obvious. And it seems marrying these two, what you produce in private sector data could result in even more valuable insights. You mentioned the use of the Globus platform to facilitate, but I know there are other challenges in establishing legal links between users and private sector data licenses. This is something the World Bank works on quite a lot. And I think it would be interesting if something that came out of this workshop would be a follow-up discussion on how we can work together on bridging what you've done with our private sector data partnerships, working on some of these challenges that you run, and see what new kinds of insights we could create. But overall, really impressive, so grateful to have had a chance to listen to you and what you've done. You should really be proud. So thank you.
Thanks a lot, Holly, for your thoughts. Now let's turn to Parmesh, please.
Thanks a lot, Haishan, and congratulations to Brian, Medha, and Julian and Robert, all to a great presentation. I think there's a lot of thought-provoking questions. My comments will be focused on how do we move from here in terms of developing a more collaborative partnership, building on the excellent work which has been already done by CGIAR. I think you have initially told about CGIAR also a little bit, that you are a consortium of so many research institutions globally, and the World Bank has been supporting CGIAR, in its formation and running for a long time. So it's like an investment which also has been done by the World Bank. And then now we are looking at the data part of it, because the conventional problem has been that there has been a lot of good research done, but it's not accessible. It's not converted into actionable analytics. And then we have not developed a protocol of how to use this rich data and analytics into designing our investments, our policy advice, and our analytical products. So this is the challenge we are facing. We have normally a 6 to 9 month window when we are preparing a project, and we need to get the best research available at that point of time to inform our decisions. Now, let's take the case of the fertilizer work which is described. We fund a lot of subsidies, investments, policy reform in the area of soil fertility, fertilization, and all that. But the data, like what you presented about what's happening in Uganda and what's happening in all, is not available at the time when we are designing those kinds of policy and policy advice. So most of the time, the advice is provided based on perception or some outdated kind of data or research which was done at some point of time. So how do we create a concurrent actionable analytics and make it so dynamic that our investments and analytical work is influenced by that so that it has the largest impact? So also the governments don't have data and digital transformation kind of thinking still in most of the ministries of agriculture we work with. So I think it's also a question of engaging in a process of institutional change where the governments take decisions on policies and also look at the whole design of institutions which are based on data and other things. So these are very strong kind of challenges which I think we need to address. Personally, I feel that we already have a lot of research, but we have not converted this into actionable analytics. So I would urge that let's pick some themes like fertility and what I think smallholder adaptation with Julian talked about. Take these themes and run some kind of joint challenges basically together. And I think there the Holly can come in because we could do a dedicated data lab part with CGIAR and bring in about 20-25 of our next investments which are coming in and then make them come together. Discover a value proposition on how we will make this work together. And so I think I'm interested in developing use cases jointly with you. And then based on those use cases, we will develop a protocol of how we will work systematically together. So I think practical idea is to do one of these challenges, not in a big kind of a place, but we do a more structured challenge with the World Bank teams which are there. So I think clearly we make about $3 to $4 billion investments every year, and we have a lot of policy advice going in. But I'm sure I can say, not with data, but with some perception that only 15 to 20% of them use this kind of CGIAR data, which is lying almost everywhere in the world, but it's not actionable. So I think my major suggestion would be that let's develop a joint collaborative work program and then have some specific use cases developed in order to inform how we will structure this partnership there, and which a lot of work which the Aishan and Holly and the whole group, development data group is doing. Because this is what you do. You do this with private sector, other partners, Google and all. The same kind of thing has to be applied to a multilateral institution like CGIAR, which has billions of dollars invested in research. But not even a small fraction of that invested in actionable analytics and use cases, basically out of that. So I would sort of recommend that we do that, and we look forward to working very closely. But today's discussion has been very instrumental in making us think very strategically about that. So I'll stop, Aishan, and I think we can go to some of the audience questions which have come.
Thank you so much, Pamesh. I really love that spirit you really shared. We need to really collaborate to turn those data into impactful use. We would be very happy to join forces. Yes, indeed, time for some discussion. Thank you very much, Laura, for having compiled the questions into some organized categories, and maybe we can follow that quickly. Just to say to the participant, indeed, the presentations and recordings as well as curated chat exchanges will be shared with all of you. So you can focus on really having engaging conversation with our speakers. The first set of questions is around getting data and publications into Guardian. How can we make our institutional data sets discoverable by Guardian? How do you ensure data is compiled using the common ontologies, especially when dealing with the individual governments whose data may be an amalgamation from local governments? What is the data quality control and assessment process? How much work does it take to make legacy data fair, and is their support for this, and how do publication gets tagged to be included in the Guardian, and is data mostly from Africa? Will we expand the region to Asia? So there are quite a few questions. I wonder whether Brian and Medha, and as well as Robert and Julian would like to come in to address any of this. You don't need to cover all of them, but whichever have caught your attention that you can respond to would be great.
So I can take a stab at some of this, at least. In terms of how you can apply those standards and how you can make your data discoverable through Guardian, there are multiple ways, really. But the two primary ways are, one, if it's sort of one-off data sets that you want to upload, you can use our FAIR workflows. As I said, that will be coming fully online in early October, and then you can use the workflow to get your data up. It goes into a Dataverse. That's the repository platform that sits kind of, if you will, behind Guardian, a separate Dataverse, and it becomes discoverable via Guardian. Now, if you want to upload it and take it or put it in another repository, you can also do that. That's possible as well. So that's one way of using our standards very quite easily in order to tag the data and make it open and fair, or as open as you want and fair, and making it visible. The other is simply to get in touch with me and let me know if you have a large data source or a repository that you feel would be useful for Guardian to sort of look at. Just send me the name and the URL, and we will have a look and do what we can to make that data visible and accessible. So that was the question about access, I think, and the application of standards. I've forgotten what the other questions were. Right, Asia. So I answered this online, and I think Julian did as well. But it just so happened that our examples were from Africa. But CGIAR itself is global, and many of our centers are Asia-based, and we are, as I said, also making discoverable data assets from a number of other stakeholders, our partners, and of course they're global as well. So there's absolutely a lot of data from both Asia as well as Latin America regions, globally, really. There's a lot of data, so feel free to poke around, and we would love it if you tackled a sort of a overarching big problem and in the way that Robert did, for instance, or that Julian has done in some ways, either using CG Labs or your own, however you approach it, and then make that data, the processed data, available back, to us as a data collection. We envision soon being able to point to these kinds of data collections, these sort of high value data collections, or as Robert said, the repositories where the pathways lie to be able to then make other data sets processed, cleaned, etc.
Thank you so much.
Yeah.
No, it's okay. You can come back to some of the other questions. I just want to apologize for mispronouncing Julian's name. I did try to ask my colleagues how to pronounce your name, but I didn't check with. So Julian, would you like to come in at this point before I turn to Robert or Brian?
Yeah, no, just very quickly. I mean, our work is global, as Medha says, and of course, data availability varies, and data quality also varies across the globe. but all of these investment planning we're doing for a number of countries. So for instance, one of these investment planning projects we have with FAO in Pakistan, and there again, we're using CG Labs capabilities and a bunch of different data sets to address the questions that were asked.
Robert or Brian, you want to come in quickly before we go to the next set of questions?
It was a question about the business model. Just to reinforce, yeah, the analytic pipelines, the data discovery infrastructure, our centers, you know, where we conduct research in upwards of 70 countries at any given time. It is a global effort. It so happens that when the opportunities come, though, to build the analytic pipelines and demonstrate the use cases, they just appear sort of by region or by use case. And so these are some of the kind of readiest demonstrations of the capabilities that we have. And it's, you know, we're obviously, you know, equipped, I think, to be able to do them in other contexts and other ways.
Great. Robert, are you expanding your research into Asia?
Oh, actually, I do a lot of that. I worked in the Philippines and I work with data from India and Nepal, so that's not a problem. I just like briefly to speak to what Vivek Prasad said. I think that was really very interesting. He said, well, you've done interesting research, but it's not actionable yet. And I agree. I mean, to one hand, I could say, well, you know, I'm an academic. But at the other hand, I would really say, you know, that would make it so interesting. You know, can we find a case, a country where you say, oh, well, these opportunities exist, the technology is available, where is there a need, where can someone, say the bank, whoever it may be, you know, bring together different parties and to really go from research to implementation. I think that's just a great idea. So I just wanted to echo that.
Thanks. I early on saw a question regarding how to ensure that we respect the business interest of commercial companies, given a lot of data are you know, from the standard driven whatever. I couldn't find it back, but I think that question was quite relevant. I don't know whether any of you had a chance to look at it and I have any insights to share. But if you know, you can come in at any time. But the next set of questions is more about collaboration with other institutions. To what extent is the World Bank duplicating effort of the CG Big Data Platform? Are regional and country offices supporting it? As well as impact and use of the platform. Are you able to track who's accessing the data and what can this tell us about who different categories of users are? Any quick response to that?
I actually, Medha and I responded to those in the chat.
Okay.
One aspect is that, I mean, the World Bank obviously funds a lot of research that happens in the wider CGIAR consortium. And so the effort under the Big Data Platform is then an enhancement to those investments to ensure the discovery and increase use of the data products and intellectual products coming from that funded research. And then in terms of you know, just kind of connection and coordination, I think that there's still actually further that we could do at a country level or at a, you know, so engaging on like a, you know, the digital dimensions of a country development strategy for agriculture or a regional development strategy for agriculture. I think there's a lot further that we could go together.
Yeah, thank you. I also noticed that in response to the early questions, how we connect with this platform from the bank side, not duplicating, but adding value. My colleague Rochelle, who is helping to manage the World Bank's Development Data Hub, has a quick comment. So Rochelle, please come in quickly. Well,
hi, sorry. Hi,
yeah, sure.
Yeah, I think it's great if we can encourage staff to add their data sets to the development data hub in the first instance, and then we can create linkages to Guardian that they can harvest directly those data sets into their broader platform.
Yeah, maybe just quickly back to and Julian, whether this is possible, we can further explore.
I think that certainly is possible. Can you hear me okay?
Yeah.
Okay. That is possible. The one thing I will say is the form that data is managed, or how that data is managed, when it goes into the development data hub, it is one option might be to use the FAIR workflows that we've developed and then put it in, take it into the development data hub. But then that way, we can be sure that the richness of the annotations is there, unless you already have ways of annotating your data sets with controlled vocabularies, with the standards, essentially. But that's a possibility. So that gives you more flexibility in terms of using the workflow, but you're not bound to keeping it just in the Guardian Dataverse. You can certainly put it elsewhere from there. But it gives you a data set that's much more richly annotated, perhaps. It's just something to consider. I'm happy to work with you on that. And I would love to know, what you're using, what the platform is, and how we go about doing that.
Thank you so much. I see there has been quite a bit of exchange in the chat, in response to some of the questions raised. So I won't go into them more. Maybe just ask our speakers if you have, a chance to look at any particular questions you would like to address, add more information, including around what is the maximum use of fertilizer recommended for maize, and it should affect the health of soil, and so on and so forth. Yeah, I leave that to you. And also, if any other participants have any additional questions you would like to raise, just raise your hands. I will just, or shout into the mic, so we can have some exchange with the speakers.
Hi, Shan, I actually wanted to say something about the data interconnectedness and things. So in a way, it doesn't really matter where the data are stored, I think, as long as you can find it. But perhaps most importantly, for people like Robert or like me doing all kind of different analysis, what matters is that you can do that as efficiently as possible. So the data, and what makes that possible is that the data follow a common ontology, for example, that the data are stored in sort of machine readable formats that you can, so you can very efficiently and quickly move on to the analysis. Today, I think we still spend, especially when using sort of field scale data and household data and those sources, we still spend more than 50% of the whole time that we invest in putting the research process in just cleaning and ensuring that the data are up to the standard for the analysis. So I think steps that can be taken in that direction while connecting the databases, the different data sources, that would be great.
Thank you, Julian. Others wish to come in? No? How about Brian, Robert, Medha, you have any additional in response to some of the questions?
Well, just in terms of that, the business model, I think Brian wanted to say stuff, and I know he is much more capable of saying more than I am about this, but to me what sounded nice was, I think Holly was the one who said, well, we're working already with a lot of, we have ways of working with private sector, and I think it would definitely benefit us to be able to leverage your experience and learn from you in that. So if we could have a more formal partnership, if that came to fruition, which I don't see why it wouldn't, then we could, I think, hopefully mutually benefit. But certainly that, in terms of the business models and how you're enabling that, that would be very useful to take on. Brian, did you want to say something about this?
Yeah, I think, I mean, the bigger, I mean, I guess the first thing I would like to say is that all of this effort is funded under the CGIAR Trust Fund, and so in large sense, it is an investment by CGIAR in digital transformation in the food and ag for research for development kind of space, and recognizing that we're not in it alone, that we have partner networks that are global and stakeholders that we engage with and interact with. And so, I mean, I think the first challenge is showing some proofs of concept level or some meaningful infrastructure investments that demonstrate the power of being able to sort of, you know, contribute to a larger ecosystem and help you know, intermediate some part of that larger ecosystem in an open way. And there's a lot of technical depth and complexity to manage with doing that, as we've been able to delve into here. I think that, you know, we'll continue doing this, and I think that we're probably in a reasonably good position within CGIAR to continue doing this and making it pretty central to how CGIAR does digital agriculture or digital agri-food. You know, at some point, I think some of these things could end up being services that we need to be charging sort of to our centers, or at some point they could be services that you know, that other folks need to join a club or a subscription or whatever. But at this stage, I think there's enough on our plates collectively as a community to just show what's possible, and then find really meaningful ways to apply it. And for, you know, some amount of time, you know, Big Data Platform will have the function of being able to support these services and these research collaborations. So a big open question and open to co-development, but I think that we're starting to demonstrate the first bit, which is the value of this kind of open data and data intermediation and applied analysis approach. Thanks.
Thank you, Brian. I share your sentiment. You know, we can't keep on creating and providing public goods without adequate investment. So a creative business model would be necessary, and the chipping in by partners in whatever way possible will be necessary. Yeah, I wonder whether our two discussant, Parmesh and Holly, have any you know, thoughts to share at this before we wrap up.
Can I also quickly jump in on what Brian said?
Yeah, please.
Because the business model question is really important. And I think I want to make quickly a few points. One is the whole open data movement is really new. And as Brian said, yeah, we still kind of have to see what it can deliver, and it will take some time. The other point is that CGIAR has really been an incredible global leader in this field. Because you know, I've been using Guardian, but also been looking at other data repositories. There's a few others, but there isn't much at all in worldwide. And so I just hope that CGIAR can also, you know, help bring the cost down to do these kind of things, but also indeed can, you know, can get the financial support from wherever it may be to play this really important role. Now, finally, even though you know, okay, I'm a white man from the Western world, but there was this interesting paper that came out in the PNAS, I think just this week, with the title, but look it up, Improving Data Access Democratizes and Diversifies the Science. I mean, they really clearly showed that by making the Landsat satellite data publicly available, diversified, you know, what is studied, who uses these data, what they study, what the regions are they study, and so you know, there's all these other aspects of if you're dealing with private companies, and of course their data is their assets, and I understand all that, but we also have to be really aware that there's the risk that if data is not public, we need to lose democracy in the sense that only a few have access, that can do research and have then a say in what is what. So there's a lot at stake here. Very important questions, but we need to keep pushing this for a little while longer.
Thank you very much, Robert. On that high note, I think it's time for us to conclude this session. I just want to thank all the participants who really really made this exchange very meaningful, and thank to our speakers, for sharing your experience with the innovation of this really great platform. And there are a lot of great lessons we can learn from. And also to see how we can adopt such approach in other areas, while also collaborating with you to continue to help refine what you have set out to do. It's just really great initiative. So with that, thank you all very much. I just want to quickly mention the next webinar on this series will be on September 17th. The topic will be Food Systems Dashboard, developed by Global Alliance for Improved Nutrition. So I hope that many of you will return to this. This is really a wonderful forum that we can all learn from each other. And so I thank our colleagues from the Agriculture and Food Global Practice for leading this. So thank you all very much. Bye. Bye.
Thank you.
Bye-bye.